Hello, this is our second part of 1.4 mini lecture. My first part dealt with radical equations and solving those. The second part will be solving equations in quadratic form. And what I did was I kind of put a little bit of equation there, kind of what they all kind of look like. You have A, B, C, just like an ax squared plus bx plus c ultimately. And you got something here and here, but this degree always doubles this degree, but these are always the same thing. So if you look at my two examples, it has that. This one's got to have an x, and this one's got an x, just like the question marks are. But if you look at this one, 1/4 and 1/2, this doubles 1/4. 1/2 is twice 1/4. If you come over here, this is not just a simple x. This one here is an x over x minus 1, and this one's an x over x minus 1. And this degree is 2, and this degree is 1. So 2 doubles 1. So both of these are quadratic form type equations. And you solve them using what we call substitution. And I gave you 4 steps of how to do this. The first step is let delta, or any other letter you like to use, like a smiley face or something like that, but you let the delta be the middle term without the coefficient. So in other words, you take this middle term right here with the question mark to the nth power, that will be what delta will always be. So in this particular case, the delta would be x to the 1/4. In this case, the delta would be x over x minus 1 to the first, whatever it is. So you discard the coefficient for your delta. You'll deal with those numbers later, though. And delta squared would be the first term without its coefficient. So in other words, the delta squared is question mark to the 2n power. So it's this thing right here. In other words, not the a. So when I have this one, the x to the 1/2 will be my delta squared. And here, this big block of terms here will be my delta squared. So what happens here, it makes the thing look a little bit more reasonable, something that you've actually seen before. So in this case, delta is equal to x to the 1/4, and delta squared is x to the 1/2. Middle term, first term without their coefficients. Replace those deltas back into that equation, you get delta squared minus 5 delta plus 4 equals 0. And that's something that you can hang your hat on. That's actually very, very familiar to you guys. So this becomes delta minus 4 times delta minus 1 equals 0. So delta equals 4 and delta equals 1. So what I just did was step number 2, solve the resulting equation for step 1 for delta. Okay? Now, replace delta from step 2 with the original middle term. In other words, the question mark to the end. So in other words, what was delta? Delta was x to the 1/4. So you'll need to go back and put the x to the 1/4 back in. So it's kind of like, when you do this, it's kind of like a temporary storage is what it is. And if you ever have any computer classes, you know it's storage. You put something in one place and you store it into another. It's kind of like a calculator. You take something and you store something in a spot, and then for later retrieval. And you want to come back and maybe use it again. And this is kind of what you're doing here. So x to the 1/4 is what delta is. So I put x to the 1/4 into delta first so I could use the delta because it's more friendlier. Then I got delta by itself, and I got to go back and take my x to the 1/4 and put it back in. Because what you're going to do is you want to solve for the original variable, not delta. And then x to the 1/4, now you have to know what x to the 1/4 is. It is actually the 4th root of x. And like we did back in a previous section, to get rid of a radical, you take that power both sides. That's actually not the previous section, it's the same section. We did this earlier in this one. So we take this to the 4th power, and so x is 4 to the 4th, which is 256. That's one answer. Now this one's going to be the 4th root of x equals 1. So you take this one to the 4th power, this to the 4th power, x is 1 to the 4th, which is 1. So x equals 1, and x is 256. So some people say, well, can't you do it without even using deltas or any of these letters? You can. It's just a little bit more trickier, and it's just hard to keep up with tabs on everything. So, and we're not going to do it that way. We're going to actually do it by substitution. That's why we want you to do it. Example 2 is the same scenario, except there's expressions in for these terms here. But the process is the same. So what we do is we let delta, and instead of being x to the 1/4, right, like this one is, In other words, the middle term without the coefficient, well, the middle term right here without the -7 is x over x minus 1. So we're going to temporarily store x over x minus 1 in for the delta. And then delta squared would be the first one, x over x minus 1 squared. Because you look at that first equation, it looks overwhelming. It's just too busy. But by putting the delta and the delta squares in there, it becomes delta squared minus 7 delta minus 8 equals 0. And then you factor it, delta minus 8, delta plus 1 equals 0. And so delta equals 8 and delta equals -1. So you've got delta by itself. Now, step number 3, replace the delta back with the original expression. In this case, what is delta? It was x over x minus 1. So that's why you want to write these down all the time. So a lot of people will store it in the delta, but don't write it down anywhere. And then when they come back and need it, it's like, you know, storing a number into your calculator and forgetting where do you retrieve it at. So you got to go back and you got to retrieve that back in. So it'd be x over x minus 1 equals 8, and x over x minus 1 equals 2 -1. And then you solve both of those equations like you did back in actually section 1.1. So I multiply x minus 1 to the other side, so I get x equals 8x minus 8. And just kind of play musical chairs with these two things. So 8's over here, and 7x now is there because 8x minus x is 7x. Divide by 7, not the 8. So x is equals to 8 over 7. Okay, and then over here, you multiply this to the other side, so it's going to be x equals -1x plus 1 when you distribute. And then add the x over here, that's 2x equals 1. Okay, and then x is 1/2. Divide by 2. Numbers aren't too bad. I mean the fractions, so nobody usually likes fractions, but it is not too bad. The answer's not too bad. It could be really weirder fractions than that. So, but I wanted you to see how that works. Oh, I just noticed something. Actually, my equation was a little slightly off. I'm going to fix it. Instead of having 18, it's just going to be 8. It's my luxury. I can change the numbers as I go along. Of course, you could do it on your homework. If that was 18, I think that would have to be a minus. When I factor this out, that would actually have to be a -9 and a +2. I think that's what it is. 9 and 2. I think that would be the right combination. So, but it works. The process is the same. So, but I'm going to change the 18 to an 8. I didn't see the 1 on there. But anyway, that's how it works. So this one has 2 answers. Okay. So when you put the deltas back in, okay, so this becomes delta squared minus 7 delta, in this case -8, not -18. And it factors to delta minus 8 times delta plus 1. And then delta would be 8, and delta would be -1. And then you take the delta, replace it back to x over x minus 1, drop it in there, solve for the x, a little bit more math. So I'm not claiming that this stuff is really super easy. They do take a little bit of time. But if you're just relax and just take it one step at a time. Remember always what delta is. Okay, get that delta in there, and that actually, when people get right here or here, it's a lot of confidence going on here, because then they know they got. I mean, the trouble goes from here to here. Once they get here, people can usually solve for delta pretty easily. So this little block of work here is pretty easy, and then it gets kind of hard again. So it goes, it's hard, easy, hard again. So, but you just got to be, patient and just, methodical. So, anyway, so this is 1.4 part 2.